All right, so now we're going to go over series, but just to tell you, this video seems a little bit long because there's a lot to go over, and we're going to go over every little step, okay? So in mathematics, the sum of numbers in a sequence is what we call a series. Adding finitely many of those numbers results in a finite series, while adding infinitely many of these numbers is an infinite series. We express a series or the sum of a sequence using the following notation. So this is what we call sigma notation. It's that weird looking E. The other thing I want to remind you is that when you are given a sequence and we're going to find the sum, okay, for the series, remember the dot, dot, dot at the end. If there's a dot, 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 that means infinite because it keeps going, right? So a finite will have a term value at the end of it. All right, so the sum of the terms, a subset n, from n to j, or n equals j to n equals p can be written as. So the idea is this. First, I need to make sure my lights are okay, so let me pause. There we go. So the idea behind this is n equals j. So in other words, we're starting, this tells you what term we're starting at, and the top of the sigma notation shows us where we're ending, what term we're ending at. Now remember, those are not the values, that's the n, the which term, okay? So a subset n would be our equation that we're using, or our formula for our sequence. The sum can be written as, now this is infinitely, right, because we have infinity at the top, so it keeps going on forever, and that has that dot, 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 okay? This symbol is, of course, sigma notation, or summation. The n is what we call the index, and j is what we call the lower limit, and p is the upper limit, okay? So right now, we're going to find the following sums by hand, okay? No little tricks to it. So the first thing I need to do is find all the values of this series to be able to add them together. Well, the way to do that is to plug in your terms. So we're going to start with the second term. So we have 3 times 2 minus 5. And then we're going to add 3 times 3 minus 5, because remember, we only use our natural numbers. 3 times 4 minus 5. 3 times 5 minus 5. And our last one is 6, because that's what it tells us to go to at the top here. Oh, 6. Minus 5. Okay, and then we can do that in our calculator, and we come out with 35. If you're worried about your parentheses and everything, do things separately. Take one more step and to say that this is 1, 4, 7, 10, and 13. Okay. All right, B. B here, it says we're going to start when the term is 1, and the last term is 4. So I'm going to write this out and then plug it in my calculator. So I get 52 over 100 to the first plus 52 over 100 squared plus 52 over 100 to the third plus 52 over 100 to the fourth. Luckily for us, we don't have to go further because it just keeps going and going and going. What we find out is in our calculator, it comes out to 0.52 repeating. Okay. As you can see, this is getting kind of redundant, and you wish there was a faster way of doing this. So hopefully we come up with one. This one, what I want you to keep in mind here, because we're not going to be able to use our calculator to come up with an exact summation, but we will be able to simplify it, not reduce. I was thinking reduce, but simplify it. What I want you to keep in mind is our term value, in this case, is not the value. Our term position is K. So when we plug in 0 to 4, we're plugging in for K. Well, as you can see in our A subset N here, X is still there. So we're not putting in a value for X. So -1, 0 plus 1, all over 0 plus 1 times X minus 2 to the 0. See how complicated that's getting? Plus -1 to the 1 plus 1 all over 1 plus 1 times X minus 2 to the first. Now I got to plug in 2, so -1, 2 plus 1 all over 2 plus 1 times X minus 2 to the second. Oh wow, I still have 3 and 4 to go in here, right? -1, 3 plus 1, 3 plus 1, X minus 2 to the third. One more, plus -1, 4 plus 1, all over 4 plus 1, times X minus 2 to the fourth. Now, yes, we can simplify this, as I said earlier. The great thing about this is anything to the 0 is always 1, but when you look here, -1 to the first is -1. So -1 plus, and if we look and we actually evaluate that out, we get 1/2 to the times X minus 2 to the first, but I don't have to write that in, plus -1/3, so I can say minus if I want, X minus 2 squared, plus 1/4 times X minus 2 cubed. One more, plus -1/5 X minus 2 to the fourth. Okay, again, hopefully you're thinking, do I have to do this every time? No, because we are going to find out other ways to help us with this. But for now, we're also going to practice going the other direction. Okay, what if we have our sequence here and we want to put it in summation? Okay, so let's remember what this means. We have our sigma notation here. Okay, remember we have our first term, which is A subset n. We have our, technically no, we have what term we start out, which will usually be A equals n. Thank you. I keep going back and forth between what term number and what value, so be careful. Okay, so we're going to start, when we have a sequence, we'll always start with n equals 1 because we have our first term. And then we have to say what our last term is. Okay, n equals, I'm just going to say last term. Now remember, that's not value. And then we have our A subset n, which is our, let's say, equation. Okay. All right, so what's given to us? Well, first of all, we know that we're going to start at n equals 1. So we need what term is 22, and we need our equation. The best thing to do first is to find our equation. So let's look at our pattern. What is happening every time here? We are adding 3, which means it's an arithmetic sequence. And if you remember from 7.1, that means that we say that A subset n equals our first term value plus n minus 1 times our common difference, which in this case is 3. All right, so could I put this equation in right here? Yes, or I could do the simplifying. So be careful when you do your homework, depending on what the computer system wants. Excuse me, guys. Okay, so if we have our equation and we know the value of the term is 22, we can find the placement of the value, the end part, by solving. So what I'm going to do here is say 22 equals -5. Now I'm going to distribute this out ahead of time. So 3n minus 3. That gives me 22 equals -8 plus 3n. And I can start solving, right? So I'm going to add to both sides. So I get 30 equals 3n, n equals 10. So I know we are going to term 10. And like I said, you could put this in for the equation, or you can put the simplified version, and I'm going to put the 3n minus 8 there. Done. All right, B. Again, we know we're always going to start with term 1. To find the equation, we have to look at the pattern itself. What is going on each time? Okay, what I want you to notice is that we're alternating, right? So when we alternate, we multiply by a negative number. And what are we doing each time? 5 halves, 5 fourths, 5 eighths. We are multiplying by 1/2. So multiply by 1/2, which means it's geometric. Geometric, lunchtime, eat lunch. We have a subset n equals the first term value times the common ratio to the n minus 1. Now there's no way to simplify this. So this is exactly what I'm going to put into my equation. And then we have to solve to get, oh, we don't need the last term. Do you guys realize? Because it's dot, dot, dot. So where does it go to? It goes to infinity. And we're done. Okay. Next, for C, what I want you guys to see is that C is exactly like B. The only difference is we do have that n value. So right now, I'm just going to start with that we have n equals 1. That's where we start. We have our equation of 5 times -1/2 n to the negative, or n minus 1, right? Now I got to figure out what is this value. What I want you guys to keep in mind is there are other ways to solve other than just trying to guess and check, because we could guess and check and just plug in n and see where we get 5 over 1024. But if you look here, this is to the first, to the second, to the third. Over here is 2 to the 0. And if we plug this in on our calculator and kept going 2 to the 2 to the 2 to the 8th to the 9th, this would be to the 10th. And I want you guys to keep in mind, this would be first term, second term, third term. Right? So the exponent is one less than where we're supposed to be. So if the exponent's 10, the term is 11. So there are a couple of other ways that we can solve for that, the placement of the term without actually solving from the equation. All right, so there are a couple of properties for summation, okay? When we have an adding or subtracting, we can separate and take the sum of each part separate. We can also talk about if we were starting at J, ending at P, and H was in the middle of J and P, we could go from the first to the middle, okay? And by the way, when we go in the middle, because we already added the value in the first summation, you don't add the same value in the second summation, you add the next term. Okay. Also, this is like scalar multiplication almost, right? You have that constant up front. We could put it in front of the summation and actually find that sum first and then multiply it by C. So on and so forth. All right, what else can we do? All right, let's focus on arithmetic series. So consider the arithmetic sequence of A subset K with the first term, A subset 1, common difference D. Then A subset K is the first term plus K minus 1 times D. So this is your arithmetic sequence equation. K being 1, 2, 3, so on and so forth. To find the summation, there are two equations that we could use to make this faster. Remember on the first page how we had the 3 problems and we had to write them all out and then add them all together, and if we had a lot, it would be a lot of time. We find that you can find the summation by saying n divided by 2, so your term, the ending term, divided by 2, times the value of the first term plus the value of the last term. Okay. The other way we could do this is if you had your number of terms divided by 2 times 2 of the first term plus, and again, minus 1d. What we need to keep in mind is you want to use the equation that's better for you. If you know the common difference here, the n value in the first term, that's good. If you know the n value, the first value, and the last value, that's good. That's going to be up to you and what you want to do. So let's do a couple questions here. Find the value of the arithmetic sum. Okay, so we're starting with 1, the first term. We're ending with the 12th term, and we know we have 4 times k minus 5. Well, I'm going to use the summation formula of n over 2 times the first term plus the last term. So one thing I want you to know is n equals 5. Now 5, why did I say 5? I looked at 5, it's 12. N equals 12 because that's the number of terms we're adding, okay? Now, how do I find the value of the first term and the value of the last term? What we do, guys, is we actually evaluate that. So A subset 1 would equal 4 times 1 minus 5, which we know is -1. Then we're going to do our last term value, which is A subset 12. So it's 4 times 12 minus 5. So when we do that, is 43. And now I can plug it into my summation formula. So 12 divided by 2 times -1 plus 43. And when we get that, we get 252. All right, another type of question that we can run into is the first term of the arithmetic sequence. Well, remember, first term is A subset 1. The 10th term, so that's A subset 10, equals -12. Find the sum of the first 10 terms. Find the sum of the first 20 terms. So we have 2 questions here. So I'm actually going to divide this in half so I know what I'm doing. Okay. So if I want the first 10 terms, well, I have the value of the first, I have the value of the second. Hey, that means I just have to use my formula. So the sum equals the number of terms. We have 10 terms all over 2. The first term value is 15. The last term value is -12. So the value is -15. That one was easy. Not -15, +15. Okay, that one was easy. But now what do we do? Find the sum of its first 20 terms. This is where you might want to use the second one, because we know n is 20. We know a subset 1 is 15. We know n is 20. And the difference is maybe what we need to find then, right? So does this actually work? It doesn't, because I don't know the difference. So maybe we shouldn't use this. So how can we find the difference? Or how, I mean, that's what we really need, is that difference, right? Well, let's go back to the last section. We have that a subset n equals a subset 1 plus n minus 1 times d. So can't we find the difference knowing that the 10th term is negative 12? It's what we did last time, right? So I know that negative 12 should equal 15 plus 10 minus 1, because it's the 10th term, times d. All right, when I solve this out, we end up getting that d equals negative 3. Now we can use that equation that I crossed out here. So maybe I didn't have to cross it out. So let me start writing it over here. So our n in this case is 20 over 2 times 2 times the first term, which is 15, plus n is 20 minus 1 times negative 3. When we put that in our calculator, we get negative 270. Now that's using the other one. Let's say we wanted to go back and use this one here. We would do exactly what we did up here. We have the first term. To find the 20th term, we could plug it into our equation, okay, to find the value, and then do this. So it depends on which one you want to use, and it depends on what information is given to us. So make sure you're paying attention to what works better. Do you want to remember both? Want to remember one? What's easier? All right, let's see what they're going to throw at us now. The first term of an arithmetic sequence is negative 12. So a subset 1 equals negative 12. The common difference, so d equals 5. How many terms of the sequence must we add to get a sum? So the s subset n is 345. So guys, what do we have here? We have a d, an a subset 1, and an s subset n. So should we use this one or this one? Hopefully you said this one. This one's going to be a lot easier, right? Because I'll show you. S subset n equals n over 2 times 2 a subset 1 plus n minus 1 times d. Okay, so let's plug in what we have, and then we're trying to find the number of terms, which is n. So this is perfect. This equation helps us all with it. So we have 345 equals n divided by 2. 2 times a subset 1 would be a negative 24. Now d is 5, guys. So I'm going to distribute that 5 out. So plus 5n minus 5. All right, let's put this together. Actually, let's get rid of that fraction. We don't like fractions, right? So to get rid of the fractions, we multiply by 2. So I get 690 equals n times, let's put that negative 24 and that negative 5 together. That's 5n. Okay, let's distribute. Now, what we find is that we come up with an n squared right here. We've learned from past math that when we look at an n squared or an x squared, we have to think about factoring. The way to do that is to get everything on one side. So right now I have 0 equals 5n squared minus 29n plus 690. This looks like a mess to factor, right? Because I would have to multiply or 5 and 690 and see what two numbers multiply to give you that, but add to give you negative 29. So actually the faster way to do this would be to use the quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, when I do that and I start reducing it down, I get that n equals, and I will reduce this down to 29 plus or minus 121 all over 10. The reason why I'm doing this is because I still want to show you that there are two answers, right? Because there's a plus or minus in the quadratic formula. Now, don't forget, you need to do your, I don't want you guys to take notes and then all of a sudden you forget where I'm getting those numbers. Okay, there we go. 2a. All right, so if I were to do this in my calculator right now, I would get n equals negative 9.2 and n equals 15. Let's go back to our reasoning. First of all, if we are counting a number of terms we have, will we have a negative amount of terms? No. The other thing we wouldn't have is we wouldn't have a decimal. Remember, they're supposed to be natural numbers. So that means that n equals 15 because it has to be a natural number. All right, let's do some application with this. On Sunday, after minor surgery, Margaret is able to walk a half a mile. Each Sunday, she walks an additional quarter mile. After 8 weeks, what will the total number of miles she walked? Okay, let's talk about what's going on. So the first day she walked a half a mile. That was the first day. So that's the first term value. Now, what does this mean? She walks an additional quarter mile each Sunday. Well, what happens is that means our common difference is a quarter mile. We know that after 8 weeks, so we're going to do n is 8, right? Because we're going for a total of 8 weeks. And we're trying to find the summation of those 8 weeks. So look at what we have. We have a subset 1, d, and n. So which equation should we be using? Well, I guess we could use either one, but let's do the one with a subset n, d, and n. So I get s subset n equals, and remember it's n over 2 times 2 times a subset 1 plus n minus 1 times our common difference. Oops, 1/4. And that's great because now we can just plug this into the calculator. Do not forget your parentheses. And then if we come up with it, we should get that the total number of miles that she walked is 11. Very good. Okay. I actually want to make sure that it comes out correctly in my calculator. So maybe you should try it right now also and make sure that you're getting your parentheses correct. And I get 11, so we're good. All right, so those are different questions that we could have with the arithmetic, okay? So let's try our geometric series. Our geometric series talks about exponential. Now, of course, geometric will have its own equation for it, and this is what I want you guys to keep in mind is this is finite. Just like the arithmetic, we had a finite series that we were doing the summation for, okay? So here we go. Find the value of the sum. So we have, if you look at the equation here, we need our first term value, our n and our r. So our first term value, so a subset n is 5. Our ratio, our common ratio, well, we did this on the front. Remember, the common ratio was -1/2. And we also did this on the front knowing that the n was 11. Okay, remember we did that on the front. So when I find the summation here, I get 5 times 1 minus -1/2 to the 11th all over 1 minus -1/2. Be careful of your parentheses. If you have to, guys, just do the numerator first and then the denominator. Also, it comes out to a decimal, so make sure you have fraction, math, enter, or FD button. So check on your calculator for the FD button because it comes out to be 3,415 all over 1,024. Okay, now this is for finite. An interesting question to explore in calculus is when is it possible to add up in infinite numbers? Okay, because finite, we got it, but infinite, there might be certain cases that it keeps getting closer and closer and closer to a value. That's what we call limit in calculus. So when we talk about getting closer and closer and closer, what happens is it's converging to a single value. And in that case, we can take the sum of an infinite series. When it diverges, when it gets bigger, that means it goes on forever, and we definitely can't count things up that go on forever. So here's the idea. Consider the geometric sequence A subset K, okay? Now, if the ratio is between -1 and 1, then we can find the summation of the infinite series, okay? So this would be the equation if we can do it. And how we know is that our common ratio is between -1 and 1. All right, so what we're going to do is practice some of that right now for infinite. We know it's infinite here because it has the ... Okay, so before we can actually find the sum, if there's any, we need to check that ratio. We know that this was the problem from the first page, okay? So our ratio was -1/2. Is our ratio between -1 and 1? Yes, it is. So since it is, we can put it into the equation S subset n equals, and it's A subset n, or A subset 1, which is 5, all over 1 minus RR. So we find that if we kept going and adding and adding and adding, it keeps, or getting closer, keeps getting closer to 10 over 3. So I'm going to keep in mind that is converging. That is why you know. The other thing you can think about this as the absolute value of r is less than 1. So either whichever one you want to memorize. I'm a little skipping on my words today, aren't I? All right, B. Well, I know it's infinite because of the infinity sign. What you need to keep in mind is when we do a geometric, we have a subset 1 times r. So in this case, r is 3 over 2. Well, is 3 over 2 between -1 and 1? It is not. So it diverges. And if it diverges, we cannot sum all of the terms up. Okay, let's look at this. A subset 1, and this is r. So r equals 2/3. Is 2/3 between -1 and 1? Yes, it is. It converges. So I'm going to write that down as a reminder. That means I can write it as S subset n equals, it is our first term value, which in this case is 3/2, all over 1 minus our r, which is 2/3. And if we do that in our calculator, we get 9/2. Perfect. All right, let's do some applications here. Okay, write the rational number as a ratio of 2 integers. Okay, well, what we find that this is 4 plus this 0.52522. I can break that up even more. 4 plus 0.52 plus 0.0052 plus 0.00052. And then it keeps going, right? Well, if you look right here, guys, right here is a sequence. It's a series. We're adding it, right? So what we need to do is actually add this part up, see if it converges, right? Because it's an infinite, and then add it to 4. All right, so what is the r in this case? How do we get from these? Well, if you look, you're multiplying it by 1/100th. Is 1/100th between -1 and 1? Yes, it is. It converges. So now we can put that part into our equation. So in this case, a subset n is 0.52. 1 minus 1/100th. Okay, this actually gives me 52 over 99. Don't forget though, we're not done, because what happened at the very beginning? We had 4. So we have 4 plus the summation of those decimals. And if I were to put this in a mixed number, I would have, or improper fraction, I should say, 448 divided by 99. All right, one more and then we are done. Okay, so we're going to relate this back to some of our exponential stuff, okay? A deposit of 500, wow, can I not read today? A deposit of $50 is made at the end of each month in a savings account that offers 6% annual interest, compounded monthly. Find the value of savings account after 30 years. All right. So the first thing you want to realize is that we're going to use the compound interest formula of A equals P times 1 plus R over N to the NT. Okay. P is the principal, which of course our principal in this case is 50. So our principal is 50. Our rate is our 6%, so don't forget to move it over twice. And n is how many times a year this happens, which is 12. All right, so if we were to reduce this, we find that we can reduce it to 50 times 1.005, 12 to the t, or 12 times t. Now, where did I get that 1.005? I got it right here, guys, when I said 1 plus 0.06 over 12. Okay, that's where I got it. Since 12t is the number of months that's compounding taking place, the payments are made at the end of each month. Okay, so let's keep in mind that we're talking about 30 years. So what we need to do is see what interest is happening over the initial deposit. Okay, so the initial deposit is 50, and it will gain interest over 12 months, right? We're doing that for 30 years, but we have to keep in mind, do we put in interest that first year? No, it's at the end of the year. So we actually have to subtract 1 from this. This allows us to know how many months, so 359 months, is adding our interest on the original $50. Okay. Now the second deposit, okay, because we are depositing $50 at the end of each month. So this is just $50. If we did $50 all together, we'd be done. But we're not. Every month we're doing it. So this is the first $50 we put in. So the second $50, let me write this down. First $50. The second $50, right? We would be doing 12 months. Oh, and I guess this isn't one for a year. This is one for months. 12 months, 30 years. But now, since this is the end of the second month, we have to subtract 2 from it. Because yes, we're doing 12 months and 30 years, but this is at the end of 2 months. So we're looking at 358. And then we keep going, right? So we have to almost subtract a month each $50. So really what we're doing when we add up all the interest, right? We're adding up this 50. Remember, we have these guys right here, 1.005. And we're doing this one for 359 months. Where the next $50, we are actually doing it for 358 months. The next $50, we're doing the interest for 357. So on and so on and so on. And it keeps going all the way until our 30 years. Okay, so we do have an ending value. All right, so in 30 years, we have 360 months. So what we are looking at is the summation of those 360 months. So I guess. So we're going to use the summation formula. Remember, this is geometric because we're multiplying. So we have our A subset 1, which is 50, because that's what we're starting out with, the original 50, right? And then we are saying 1 minus our rate. Remember, our rate, or our common ratio, what we're multiplying each time, is 1.005. and we're going to multiply that by our n. Well, our n is not multiplied to the nth, which is 360, all over 1 minus our common ratio. So again, where I'm getting this from is this is our series. Okay, our a subset 1 is 50, and our common ratio is what we're multiplying by, so 1.005, and we're doing this for 360 months because it's compounded monthly. Remember that. Now I'm going to put it in our geometric series summation for finite, and when we get there, we do this on the calculator, we get 50,225.75. Think of that, guys. So every month, if you deposit $50 for 30 years into an account that has a 6% annual interest, then you will make $50,000 in 30 years. All right, let's see what we can do. Remember to make sure you are grabbing the right formula to use for your summation. Look at what's given to you and how you can find the missing terms.